All right, on to the exclusively G period problems. Let's take a look at these. Pretty exciting. So we've got a box pull to the right, we've got acceleration, we've got a tension, so many things happening, and what we want to do is figure out the acceleration of this box. So let's start with the free body diagram. I have this tension, it's equal to 40 newtons, and I've got an X and a Y component to this tension, which I'll write like this. There's a friction force, and there is the mg weight force pulling down. Now, one thing I want to say here, in this case, friction is not equal to mg. A lot of people wanted to just jump ahead and solve the problem that way. That is not correct. No. All right, now to this end, let's set up equations in the x and in the y direction. So vertically, I have Ty. Oh, there's one more force that's missing. There's the normal force acting up on the object. So we have the tension in the y direction and the normal force. Downwards, we have the weight, and those forces balance. And then the other equation we have in the horizontal direction is that the horizontal component of the tension battles the friction, and the effect is that our box accelerates. So this is in the y direction, and this is in the x direction. Let's start with the y direction equation to get a value for the normal force. So Ty, just so you know, is going to be 40 times the sine of theta, and that's going to be 30 degrees. And so when we work that out, that's going to be 20 newtons. And then Tx is going to be 40 times the cosine of 30 degrees. When we actually work that out, let me just do that real quick. So 40 times the cosine of pi over 6. Spotlight does this, but you got to do it as a radians measure. That's 34.64, or 34.6. All right, now let's plug that into our formulas. So, speaking vertically, we have 20 newtons plus the normal force minus mg, which is going to be 5 kilograms times 10, equals 0. So I'm getting a normal force of 30 newtons. Now, horizontally, I've got Tx minus the friction equals m times a. And I can say that Tx is 34.6 minus mu times the normal force equals m, which is 5 times a. Continuing on, 34.6 minus 0.3 times our normal force, which we got as 30 newtons, equals 5 times a. So I'm going to end up getting 25.6 equals 5 times a. And the acceleration is going to end up being 5 point, I think it's 5.012. Let's actually just figure that out though. 5.12. Whoops. So 5.12 meters per second squared. So that wraps up problem 7, and I'm going to do problem 8 in a few minutes here in the next part.